Hi, everybody, and welcome to Math with ACE. We're focusing on statistics and probability today. We're going to be working through a variety of examples and how you would calculate different types of probabilities. So our first example here, we have a situation where we're trying to decide whether we can determine if we were sampling with or without replacement. We have a fair, well-shuffled deck of 52 cards, which consists of 4 suits, which are clubs, diamonds, hearts, and spades. And then there are 13 cards in each suit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, and King. It's actually not a 1, it's an ace. Suppose you pick 3 cards. The first card you pick is the Queen of Spades. And then the second card you pick is the 10 of Clubs. And then the third card you pick is the Queen of Spades, which that's a little interesting as you first originally picked the Queen of Spades. So if you pick a Queen of Spades, but you don't put it back, you can't pick it again. So the only way that you could pick the Queen of Spades twice is if you were sampling with replacement. So for the first one, we are definitely sampling with replacement. For the second option, you pick 3 cards. The first card you pick is the King of Hearts. Then you pick the 3 of Diamonds, and then you pick the Jack of Spades. Now, because of the wording of the question that says which one is sampling with and which one is sampling without, we know that this one has to be the other option, that this is sampling without replacement. So the first one was sampling with replacement, the second one was sampling without. If it wasn't worded that way, there's not a way to guarantee which one you're doing when you have all unique cards, because maybe you just lucked out and got all unique cards. Okay, so the key indicator here was the fact that we had a duplicate, and the only way that you can get a duplicate is if you were sampling with replacement. Let's move on to our next question. Here we have a fair, well-shuffled deck of 52 cards, and what that is telling us, again, is that there's not one outcome more likely than the other. It's really important that we do say that it is well-shuffled and it's fair. It consists of the 4 suits. We have the different numbers that are included as well. And it says, suppose you pick 4 cards, but you do not put any cards back. Suppose your cards are the Queen of Spades, the 1 of Diamonds, the 1 of Clubs, and the Queen of Diamonds. Which of A or B did you sample with replacement and which one did you sample without? So just like the previous one, if we're looking between these two, one has to be with, one has to be without. I'm looking for duplicates. And each of these cards are unique. Okay, I had the Queen of Spades, the 1 of Diamonds, the 1 of Clubs, and the Queen of Diamonds. I play cards. It's not a 1, it's an ace. That's annoying to me. So I'm just going to go ahead and go like this. Fix my own problem. All of those are unique. So right now I'm not guaranteed to know which is which. In the second example, I pick 4 cards and then I put each card back before I pick the next. Well, if I put it back, that's sampling with replacement. Same type of question, trying to determine whether we're sampling with or without replacement. So the biggest thing that we're looking for here is whether or not we have duplicates. Suppose we pick 4 cards. We have the Queen of Spades, the Ace of Diamonds, the Ace of Clubs, and the Queen of Diamonds. Those are all 4 unique cards. Then again, suppose I pick 4 cards. I have the King of Hearts, the 7 of Diamonds, the 6 of Diamonds, but then I have the King of Hearts again, which is a duplicate. And you cannot have a duplicate unless you are sampling with replacement. So by default, A is sampling without replacement, and B is sampling with replacement. And the only way, again, for A that I can know it's without replacement is because it's telling me one of the 2 has to be with and one has to be without. All right, next question. We are flipping 2 fair coins and we have a sample space of heads, 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 tails, tails, heads, tails, tails, where T is tails and H is heads. And we have the outcomes listed, which are in the sample space. The outcomes, heads, tails, and tails, heads are different. That's because heads, tails means you flipped a head first and then a tail. Tails, heads means I flipped a tail first and then a head. So let A equals the event of getting at most one tail. List the outcomes in event A. So event A is equal to at most. So I can only have one tail or less. Heads, heads, that's good. Heads, tails, that's good. Tails, heads, that's good. But tails, tails has 2, which is more than at most 1. So at most means equal to or less than the value. That's a hint, okay? B is the event of getting all tails. So the only way that I can get all tails is if I get tails each time, which is tails, tails. Now we're going to calculate the probabilities. Notice in our sample space, there were 4 outcomes total. The probability of event A is then there are 3 options in event A, so 3 outcomes out of 4 total for the outcomes of the total sample space. Probability of B is equal to only 1 outcome out of the 4 total. C is the event of getting all heads. Are the events B and C mutually exclusive? Well, let's see. C is equal to all heads, which is heads, heads. B was equal to tails, tails. Can you get heads, heads, and tails, tails at the same time? No, you cannot. So yes, they are mutually exclusive. D is the event of getting more than one tail. Calculate the probability and list the outcome. So if D is getting more than one tail, that means I need 2 tails. And there's only one way to get that. And the probability of that is equal to 1 outcome out of the 4 total in the sample space. E is the event of getting a head on the first roll. We're going to list the outcomes and calculate the probability. A head on the first roll could happen if I'm looking at my sample space above. I have heads, heads, that's a head first, yes. I have heads, tails, that's a head first, yes. Tails, heads is no. Tails, tails is no, because those have tails first. So then the probability of event E, there's 2 outcomes out of the 4 in the sample space. Event F is getting at least 1 tail and 2 flips. So we're going to list those outcomes, and then we're going to calculate the probability. At least 1 tail. So at least is different than at most. At least means I need 1 tail or more. Heads, heads does not have any tails. Heads, tails has at least 1. Tails, heads has at least 1. And tails, tails has at least 1. And the probability of F is 3 outcomes out of the 4 in the sample space. So let's write down at least means equal to or more than the value. Hopefully this was helpful. Thanks for watching.